Okay, chemistry students, lesson 4.5, we're going to continue looking at the quantum atomic model. And in this lesson, we have two objectives. Number one, we'd like you to understand what the four main electron energy sublevels look like in the quantum model, at least what we think they look like. And number two, to understand the idea of an electron cloud and how the atoms, or how the electrons, are arranged according to the quantum model in the electron cloud. So this would go with the reading in chapter 6.3, and there are a couple of post-video questions at the end, so we will look forward to discussing them with you tomorrow. Let's get started. So first of all, the graphic that you're looking at, you do have in your packet. You're going to want to look in your student packet on page 32, and any marks we make on here you can make on page 32. Yours is black and white, but it's the exact same graphic. So what we were looking at here is the different sublevels that an electron cloud can have, and basically we want you to learn to identify those by their shape. Especially we're going to focus on the S and P. The D and the F are a little more complex, as you can see, but let's start with the S sublevel.
All right, well, the S sublevel is the most basic. It is simply just a sphere, and this would be your ground state energy level for things like hydrogen, lithium, helium, and the like. If you notice, if you rotate it on X, Y, and Z, it stays the same. So there's no orientation for the N or the S sublevel.
Okay, it's a spherical cloud. There is an S sublevel on each main energy level.
Yep.
And it's the lowest energy sublevel on each level. So you're always going to start with an S sublevel. So if you think of it as like an apartment building, I guess, the first apartment that ever gets occupied on a given floor is going to be the S.
Yeah, well, we're getting ahead of ourselves right there, because that's not until electron configurations. So the second type of sublevel we come to is the P sublevel. This one is somewhat known as the dumbbell shape, or, you know, it kind of looks like an infinity sign to me. But this would be the second highest energy level, or the second lowest energy level. This is found, like, again, we're talking about this later on the periodic table where to find these. So right now you should just know that there are three different P sublevels. There's the P-1, P0, and P1. These are also known as the PX, PZ, and PY. The reason they're like that, if you notice, the P-1 is on the x-axis, that makes it PX. The P0 is on the z-axis, makes it PZ. And the last one is PY, because it's on the y-axis. And if I rotate this, it would change its orientation. Notice there's a yellow lobe and an orange lobe. That means one side is positive, the other side is negative. That means these things do have orientation to each other, so you can rotate them and get a different orientation. The next one down is the D sublevel. These ones are often described as clovers. It's the clover sublevel, with the one in the center kind of...
looks like a sort of a p orbital with a donut around it.
So, I mean, if you were to know these ones as clover shaped, that would be the most generic definition for them. Again, notice they do have different orientations. There's the D2, -2, the D-1, the D0, D1, and D2. That's just telling you their orientation in space. Are we going to expect you to know these ones? No. But again, you can see there's dark blue and light blue. That's the positive and negative lobes, and it just shows you how they're lining up. And if you rotate these, you'll get something entirely different. The last one is the F orbital. You should be able to recognize these on sight because they are the most busy looking ones. You just look at all the different lobes shoved in there. So
I call this F, it's the flower shaped lobe.
I guess that works. But it's very busy. It's very different than the other three. You just have to be able to recognize that it's an f orbital on site based on its stark difference from the other ones. You have the s orbital, which is a sphere. You have the p orbital, which is a dumbbell. You have the d orbitals, which most of them look like clovers, except for the one that kind of has a dumbbell and donut hole added on.
Right,
and then
the middle one in both D and F has kind of that same thing.
And then just need to recognize these on site.
And we should recognize how many numbers of orbitals are associated with each. So the S, there's one orbital in the sublevel. P, there are 3, so one orbital in an S sublevel. Orbit.
You clicked off with your hand.
3, the P sublevel has 3 orbitals.
The D has 5, and of course the F then has 7. So later on that'll mean more to us, but just be aware of these differences and aware of these number changes. Alright, let's take a look at what the actual quantum model is going to look like now.
So here's what it looks like if we take the first s orbital, which is this smaller dark purple shaded area, together with the second s orbital, which is this larger one.
And then you have some p orbitals. You notice there are a total of 6 lobes shown. That's all 3 p orbitals occupying the same general region of space.
One of them. There's the second one, and the third one you can think of as sort of projecting almost right out towards you and away from you.
And if you notice, the third S is right there. You can see they're not separate from one another like we saw on the other one. They're all overlapping and are potentially in the same area. This is what's known as your electron cloud. So all of these here would be your electron, writing with my finger now, cloud, ran out of space. So these are all your electron clouds. They're all overlapping, and these are all statistically found in one area. So if you want to write that better somewhere else.
So if you take them all together, electron.
Yeah, so these are all the electrons. So notice still the nucleus is a small part right in the center, right here in the center. It's still small, dense, and positive. But the electrons are still taking up the majority of the space, so it's not changing what we learned from the Bohr model, it's just improving its definition.
And now each of these different places where an electron is would be associated with a different quantum amount of energy, and that this model actually explains all the different emission and absorption spectrum.
Explains emission, absorption, bonding types, explains a lot, but we're not going to get into it because it just gets difficult and hairy pretty quick.
But basically an electron that is in the ground state is going to be spending almost all of its time in this region.
You have one electron that's ground state will be there.
One electron is ground state. An electron that is in this orbital would be spending its time in the 2s orbital, which does overlap with the 1s orbital. If it's in one of these p orbitals, if it's in this p orbital, it's going to be down here or up here, okay, depending on which of the p orbitals it's in. If it's in this one, it's either over here or here, and this would be the region where we could statistically expect to find the electron most of the time when it has a certain energy.
Yeah, and all these shapes were calculated from the Schrödinger equation. But right now, just be aware of this is what the quantum mechanical model looks like. We have the electron cloud on the outside with different shapes, but they're all overlapping to some degree. And also be aware of the different geometry looks of them, the sphere, the dumbbell, the clover, and the flower looking one. Otherwise, we're done with you for now, and have a good night.
Okay, as promised, we have 2 post-video questions for you, and I kept them both kind of on a practical level for you. Number 1, how would a chemist designate the spherical sublevel on the 3rd electron energy level? So remember, these sublevels, energy sublevels, have different shapes that we believe that where the electron is occupying some place in that region. What is the designation for the spherical shaped energy sublevel on the 3rd electron energy level? Question 2, describe the shape that a p orbital sublevel would have. So give those a try, and we'll discuss them when we next meet.